Hi, I'm going to I will teach you about the calculation topic in the Sigma, some overview. Okay, because it seems that most of you don't understand about the topic that involve calculation. Okay, so first you must know what is the DMIC. Okay, understand what is every phase involved. Okay, what is D, what is M, what is A, what is IC, and what is the activities inside the every phase. Okay, about the calculation. Okay, first about the calculation of DPMO. Okay, this is the examples. Okay, where you can see that uh, the formula for DPMO is actually defects time 1 million over defect opportunity. Okay, time units. As example here, the toaster is determined to have 52 opportunities. So this is the opportunities, defect opportunities, and then this is the uh, units. Okay, 1000 units, and then this is the defects. Okay, 975. So the DPMO value is 18,750. Okay, from this, okay, we check to the Six Sigma value, Sigma level. Right, the Sigma value level, if the DPMO is 18,700, it means 18,700 is around here, between 19 to 16. So we can say that is about 1.35 Sigma value. Okay, so this is the Sigma value for the this process. Okay, so about the CPK, okay, you must understand. Okay, CPK is the potential capability indicator how well the process. Okay, could be if it were centered on the target. If it was centered, so the CPK does take into account the location of the data by considering the closeness to the means. Okay, the means and the target is different. Target is what we want. The means is the average of the result that we get. It's not supposed to be as the target. Okay, so this is the Sigma value for Motorola that you need to understand. Okay, what is the, if the value you get less than 1.0, okay, what is the capability, and then also if you got this, and then what is the Motorola level above 2.0. So how to calculate it, I will show you later. Okay, the CPK, the CP is this. Okay, you got upper limit, lower limit, and then you divide by 6 times the standard deviation. Okay, this is the CPK. So you get the value CPK. And then about the this is the CP. For the CPK, actually, you take the upper limit, okay, minus with the average, the means, okay, divide by 3 standard deviation, 3 times standard deviation. And then you can calculate another value. So that is this is the formula. So you compare between this, which is minimum. Okay, with the modulus. With the modulus means that even you get the negative result, you make it positive. Okay, so which one is the minimum? So that is the CPK value. Okay, maybe here, or maybe this or this. Alright, so if you got the CPK value for Motorola, is actually 1.5. Okay, this is the standard, so you must understand this. So it seems like this. Okay, you see if your distributions. Okay, distribution means at 1 million try, the result is within this curve with the bell. Okay, most of it in here. Okay, so if you got the CP, the best is CPK and the CP is at the same value. It means that the CP is 1.67, also the CPK is 1.7, because they are the mean and the target is same at the center. In case that you get this, all your result testing is fail because it's all below lower limit. So the CPK should be less than 1.0 because it's very far from the target. Okay, because the mean of the your process is here, but the target is here, so very far. Okay, so capability is okay because it's sharp. Okay, the efficiency is good, but it's very far from the target, so it's not centered. So for this case actually, okay, the CPK is less than 1.0. Okay, because of very big very big curve, and then some of it is out of spec. Yeah, okay, so it's centered, but the capability is very less. Okay, but here also most of it is not capable because the the center also no good, also is out of the target. So this is the meaning of CPK. Example is like this. Okay, food served as restaurant should be, this is the minimum, this is maximum. This lower limit is maximum, upper limit. So it will deliver to the customer. Okay, the process used to keep the food at the correct temperature. Okay, so the standard deviation, this is the standard deviation S. Okay, 2. So the mean value is 40. So how you calculate it? Okay, take it as a process capability. Okay, this is the CP. You get the 0.7. So the CPK, we try to both side. Okay, first side is upper limit is 1.5. The lower limit is 0.166. So we take the minimum is 1. Okay, so the process capability minimum is 0.166. Okay, so this is the CPK. Alright, this is the R value. Okay, if you get a graph, okay, you test a data, okay, you may test it with the linear calculation, or you regress it to the quadratic. So compared to this, okay, you choose the highest R, higher R. Okay, so in this case, this process is better to use quadratic because the R square is higher than this value, this linear. So anything involve the calculation, we will use this formula up here. Okay, so this is a cause and effect matrix. Okay, cause and effect matrix is for you to 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 see what is the importance of the process. So let's say like this. Okay, the okay, the important is this. Okay, this is more important, this is less important. So this is the correlation for input output. Let's say you put that uh, the what is it the weightage as 5. It means the important of this patient schedule is 5, but the arrive improper is 2. So the dress properly is only 0. Okay, so you can get that the process output is 39. This one times this plus this one times this. Okay, 5 times 5, 25 plus 2 times 4, 8. So 25 plus 8, 39. Is it? Oh, plus 3 times 2 plus 6. So you get 39. So this is the cause and effect matrix. Okay, you master this, how to take it, to put this weightage. Okay, the higher is the more important. Okay, this is the important of this. This is the important of this process. This is the important of this activity. Fixed already, but this is the process involved. So after this, we can get the rank. We can rank it, which one is important to study. Okay, so the RPM. RPM is for the FMEA. Okay, RPM is come from the risk priority numbers. Okay, this means what is the highest risk. Okay, for as this process, okay, you see the touch screen is actually there is potential failure. That is crack, broken, scratch. So if this happen, the effect will be reject touchscreen. So the severity for this, okay, is imagined being as 9/10. Okay, the highest is 10, so 9. So it's 90%. Okay, it's about 9/10. So, but and then also the potential cost because of the low quality. And how about the occurrence? Okay, is it the cost is easy is likely to likely to happen if the higher the likeliness, so the occurrence also very high. Okay, so it's 9/10. It means it's very likely to happen. So and then the current controls is what is the current control you perform to detect this reject. Okay, so this current control is visual inspection. Visual inspection is very less detection value. So you take it high. Okay, if you got like sensors everything, you maybe get only one because the higher the detection, the lower the higher the uh, detection quality, so the lower the detection value. Okay, so from this you can see that 9 times 9 times 8 equal to 649. So you rank it. So this is one of the highest that need to take care. So in this case, is in case that you can increase the detection level, maybe from 8 to 5, so the RPM will be reduced. Same like this. You perform the functional test to detect the sensor, to check the sensors. So in case that we can improve this with some automatic sensors or what, it should be detection maybe lower. Okay, then RPM, the total RPM should be lower, right? So that's all for the calculation. So don't worry, this is a very simple calculation. So all the best. Thank you.